Welcome to our second tutorial here at TIP Biosystems. Today we will be walking you through an actual application, namely the determination of protein concentration in two unknown samples using our PhotoPad in order to show you how you can integrate PhotoPad in your everyday workflows. Along with the two unknown samples, I have prepared 5 reference samples using a BSA standard. These reference samples have a concentration ranging from 0 to 1.4 microgram per milliliter. And my first step will be to mix the 0.1 milliliter in each of these vials with the Bradford reagent. Adding 3 milliliter of the Bradford reagent to the 0.1 milliliter of the sample. This step will be repeated for all of the samples. "40 minutes have passed and we are now ready to measure our samples using PhotoPad. The first step will be to remove the protective cap from the PhotoPad and place a measurement curve tip on the device. And then select our blank sample, which consists of 3 milliliter Bradford reagent mixed with 0.1 milliliter of pure DI water. I gently insert the measurement curve tip in the solution and make sure that no air bubble is trapped inside the cavity. In order to start the measurement, I press the measurement button located on top of the PhotoPad. And we now can also take multiple measurements on this blank sample to make sure that PhotoPad really is giving absorbances around 0. For each of the samples, I will take a total of 5 measurements. On my screen, I can see the absorbance values displayed, and results are close to 0 as expected. I then discard of the used curve tip using the tip box ejector. Place our reference sample back and then go on to the next measurement curve tip. The first sample measured is one of the BSA standards of concentration 0.1 to 5 milligrams per milliliter. Again, I will insert the curve tip in the solution, make sure that no air bubble is trapped inside the cavity, and then take 5 consecutive readings. The absorbance value that I can see on my screen now is about 0.045 absorbance units. Again, I discard of the used curve tip. Place the next curve tip on my PhotoPad. And then repeat the whole process for all of my samples. Now that we have recorded all of our data points, we can continue to build a custom application using the PhotoPad app's Method Maker. The first step will be to select the corresponding dataset, which I renamed to Bradford Tutorial. The units for my concentration was milligrams per milliliter, and I will choose a calibration fit as linear, though I also have different options. For the Bradford assay, only the 600 nanometers are available from the dataset. The next step consists of inserting the concentrations for all the different data points recorded. The last measurements were on the sample of concentration 1 milligram per milliliter. Now, as mentioned previously, I recorded 5 data points for each concentration, but we can also choose to exclude a few of the data points if desired. The next concentration is of 0.015. Again, I choose to exclude a random value. Then followed by the first sample which I measured at 0.5 milligrams per milliliter. And of course our reference at a concentration of 0 milligram per milliliter. Continuing then actually gives me a plot of the recorded data. The R-square value in that case is of 0.985, and we have the option to rename our method. We can insert the name of the person who created the method, and also have the option to leave instructions for other users or for our own reference. As a final step, we can create the method, and once we connect to a photo pad which supports the required wavelength, we can then see the measurement type that we just created under the application types, here listed as My Bradford, which we can select and then start measuring our 2 unknown samples of which we are trying to determine the concentration. Now that we have created our custom application, we are ready to determine the concentration of our 2 unknown samples. After connecting to our photo pad, we select our custom application from the measurement type. And as always, start out by taking an auto-reference measurement in our reference solution. I will also take a few readings in this reference solution in order to verify results are close to 0. As expected, results are very close to 0, and we can continue measuring our first unknown sample. I discard our used filter and place a new one on our photo pad. For our first unknown sample, I will take about 5 readings. Now, since we are using our own custom application, the PhotoPad app does not only display the absorbance value, but also the concentration value along with it. In our case, I see an absorbance of about 0.34 absorbance units, which corresponds to a concentration of about 0.42 milligram per milliliter as calculated by the calibration curve which we defined earlier. Let us now measure our second reference sample, for which I place a new prüfstück on our device, and for which I will take again 5 readings. For our second unknown sample, I see an absorbance value of about 0.61 absorbance units, which corresponds to a concentration of about 0.77 milligram per milliliter. You now learned how to use PhotoPad in order to determine the protein concentration of unknown samples. We hope you will enjoy working with PhotoPad, and if you have any questions, feel free to contact us at support@tipbiosystems.com. And stay tuned for more tutorial videos to come soon.